and trying to elicit as many strategies as possible from the students. Since students frequently do number talks, the purpose of these number talks is just to develop fluency and flexibility with two-digit multiplication. So having the students give as many strategies as possible and then making connections between these strategies is really the purpose and goal of this number talk. So as always, I look forward to learning together, so please leave your feedback, thoughts. If you try it out, I'd love to hear about it, and I hope you enjoy the video.
Okay, class, today what we are going to do is a number talk. I'm going to put one problem on the board, and your job is just to figure out as many ways as you can to solve this problem. You can just give me a thumbs up when you have an answer and strategy, and then if you're waiting before I start the conversation, if you want to think of another way we can solve the problem, or a third way we can solve the problem, that would be great. Okay, bless you. The problem that we are working on today is 18 times 35. Let's take some answers first, and then we'll talk about strategies. Who has some answers for 18 times 35 for me? What did you get? I got 630. Anybody else have a different answer? Everybody got 630. All right, so let's start talking about strategies. How did you get 630? The answer was 5. Jackson.
I used standard algorithm.
Okay, so tell me what that looks like.
You put the 18 on top of the 35.
On top of the 35, okay.
So first I did 5 times 8, and that equals 40.
And how do you write? Do you write 40 down here?
I put the 0 right there, and then I put the 40 on top of the 10 space.
Okay.
And then I did 5 times 10, and that's 50. And then I put it, and then I added 40 plus 10 plus 50, and that's 90. And then put that down there.
So do you put the whole 90 down here?
Yeah, just 90 right there.
Oh, just the 9, so it made a 90. Gotcha.
And then I used 30 times 8, and that's 240. And I put that under 90.
Which is 240?
Yeah.
Okay.
And then I did 30 times 10, and that's 300.
Here?
Yeah. Okay. And then I added all of those together. And 0 plus 0 plus 0 is 0.
0?
9 plus 5 equals 13, so that's 130. And then I put the 1 on top of the, and then 1 plus 2 plus 3 equals 600.
630. Wonderful. Very good. Another strategy for 18 times 35. Yes.
So I did 10 times 35. And I know 90 plus 350. And then I did 8 times 30, which equals 240. And then I did 8 times 5, which equals 40. And then I added them together, and then like 0 plus 0 plus 0 equals 0. 50 plus 40 plus 40 equals 130. So I put the 30 down there, and then the 100 there. 100 plus 300 plus 200 equals 600.
Anybody else use that strategy?
No.
I see some shades. Can somebody who used that strategy tell me where is the 18 times 35 in this work right here? Where is the 18 times 35? Where is that?
It's in two equations. It's the 10 times 30 plus the 8 times 30.
So 10 times
35, and then the 8 times 30, and then the 8 times 5 added together.
Oh, so you see the 18 here?
Yeah.
All the way down here? And why is the 18 broken into those three parts?
Well, you have to add the she only did 8 times 30 there, so she still had to do the 8 times 5, so she had to do 8 to get to 35 again.
Gotcha. So that's why we have two of these 8s here.
Yeah.
Very good. Another strategy for 18 times 35. Yes.
So since I knew 18 was really close, well, it was close to 20, so I rounded 18 to 20. I know 20 times 30 equals 600.
20 times 30 equals 600. Okay.
Yep. And then after that, 20 times 5 equals 100. So then I knew that I added 2 more to get to 20, so 35 is 30. Well, 35 times 2, which is 70. And then I added them. And then after that, I got 700. And then 700 minus 70, which got me to 3.
So those two gave you 700,
700,
and then 700, I'll write that down here, minus the 70
Yeah.
equals 600. Good. Anybody else re-explain that for me? How did he adjust this problem here? I re-explain that. Shannon, what did he do?
He added 2 to 18.
Oh, so this 20 is
No.
an extra.
He had to do the 35.
Oh, so he has an extra 2 groups of 35 right here. Okay.
So then he got 20, which was easier to work with, and then he got 20 times 30. Well, he broke up to 35 into 35. And then he had 20 times 30 and got 600, and then 20 times 5 and got 100. And then he did 30 times 2 is 70, and then he had to subtract those two, and so the 700 minus 70 equals 600.
So this is the 2 groups of 35. Very good. Another strategy. 18 times 35. Another strategy. James.
I took I know 18 is close to 20, and I did 20 times 35, and that is 700. Then I took and then I had to take away 2 groups of 35, and 35 plus 35 equals 70, and 700 minus 70 equals 630.
Do you see that the same or different than what he did up here?
I just didn't do the first 2 problems.
Oh.
I did 20. I did 20 times 35 instead of 20 times 30.
He chopped up the 35. Yeah, he didn't chop up the 35. Good. Wonderful. Another strategy. 18 times 35. Yes.
I did sort of with the area model in my head.
Okay.
Kind of different because I didn't actually have the area model in my
Okay.
head. But it's like the same thing that you would do with an area model.
Okay.
So
Can you describe what it looks like to me?
it's sort of like a bunch of problems that in the same fashion of which you would put into an area model.
Okay.
Or the answers at least.
An area model, you're seeing a rectangle in your head? Is that what you're
A square.
A square.
So I put 10 and 8 and put that up.
And do you just split it right down the middle?
Yeah. Now I did 10 and 8, and then I just kind of put the line down right before 8.
Okay.
And then I did 30 and 5.
And we just split it right across here? Yeah.
First I did 5 times 8, and then that was useless.
And where does that go in here?
Okay. And
Okay.
then I did 30 times 10, and that's 300. I did 5 times 10, which is 50, which is here, but then I just like immediately knew that that's just 300 plus 50, so I just turned it around.
Okay.
And then I would and then look 30 times 8, I added 40 to get 390.
You added all 3 of those and got 390. Okay.
390 because I doubling.
Right.
Then I did 30 times 8, which which is 240. So I added 240 to 390, and I got 630 with the 0, the 0, the 0,
Mhm.
the 15, add the 1 on top.
Thank you. Anybody else? Another strategy, and since it seems to be this is equal to 630, I'm going to write that here so I have some space. Another strategy for 18 times 35. Okay, I'm going to challenge you with your neighbor to come up with one more strategy for 18 times 35. Return.
Maybe we could do like small factors or doubling and halving.
Remember we learned that earlier. Yeah, we have strategies for starting. Maybe in the double and halving. That way we're going to come back together 8 times 6 and 3.
Awesome. Thank you, guys. I know it's hard to stop talking about sometimes. Another strategy, 18 times 35. Lindsay, what did you and your partner talk about?
Well, it was group 3.
Oh, great, good.
Came up with halving and doubling.
Okay.
And so what you would do is you would half the 18 to make it 9. And then you double the 35 to make it 70. And we knew that 9 times 7 was 63. And then 63 times 10 would equal 630.
Somebody else had that idea too. So I think they can explain to me what's happening when we double and half, because we know we're getting the same product here. What is happening, maybe in an image or a representation, when you do that? What is happening? What's happening?
So what's happening is that all that we're doing is that both of the numbers, like when you're doubling and halving, you're just doing like a number that would be equivalent, or you're doing an equation that would be equivalent to the other one, but with one number smaller than it was before and one number bigger than it was before.
Gotcha. So it's like we're making one a certain way smaller, we make the other one a certain way bigger.
Mhm.
Good. Does anybody want to add on to that about double and halving? Yes.
So when you're doubling half, like you can't just like double both of them or half both of them, because like if you want to get the right number, you have to half one and double one. That's what, because when you double both of them, you don't get the it's like almost one more like it's one more group of 35. So when you double and half both, then it's also easier for me. I forgot.
Yeah. Good. And so add on to that. Are you adding on to it?
Yeah,
Go
I
ahead.
kind of think of it as, this is like weird, but I kind of think of it as like fractions. Like if you're reducing a fraction that you take and you kind of you can multiply them, you can do it on the denominator. I kind of think like if I wanted to have this, what would be a smaller number?
Okay. So you kind of like fractions. Good. Adding on still, Katie?
I kind of think that you just want half. That when you half, it's divided by 2. And when you double, it's multiplied by 2.
And it's going to keep the same product. Good. Shannon?
I think of it as like you're kind of having less in each group, but more groups. So like instead of having 18 groups and only doing it like 35 times, you're taking the 18. Like you're taking you're kind of taking the one group of you're taking your one group and halving it and making that into 2 groups, and then you just have more groups of that.
Gotcha. So we have more groups with less in it. Good. So we could have half as many groups and more in each group, or we could have more groups with less in each group. Good. Still adding on to the doubling and halving. Yes.
So I kind of think of it as an array, like a long array.
So like she saw in her image on her mind.
And it's kind of like a rectangle, and then you take one side of the rectangle and add it to the bottom of it.
Gotcha. Can you give me some numbers to relate here to this, and then we'll talk about what's moving.
So, make that 10,
This?
Yeah.
10.
and then the other side 5.
Okay.
You, let's say, we're gonna half 10 and then double 5.
Okay, so half, you mean like cut it in half?
Yeah. So you
That was funny, right?
so
We
you,
all see what's happening.
you cut it in half, and you take the right side, you add it to the bottom. Now it's 10 and 5.
So if I move this, that's great. What property did you just show right there? So then you move that right there, right? Yeah. And what are your new dimensions of your new right side?
5
So 5 and it's still 50, right? Can you give me the two equations that would match what you just did?
So I would go 5. I would do 5 times 10,
Right.
and 10 times 5.
And then once you move it,
example ever.
yeah, that was good. So if we were changing that here, so you were just giving an example that would work here, and then in our picture it would be halving the 18. So this would maybe be the 18. Good. Do we have a different strategy for 18 times 35? Katie, did you have one last thing to add? Okay, go ahead.
I actually had another way of picturing doubling and half instead.
Okay.
I kind of imagine it as like a balance beam in a way.
Uh-huh.
Like kind of like one of those catapults. But basically, I think if you have to double in an equation, you have to remain the balance kind of by halving. Otherwise, the equation's not really balanced.
So I kind of see you doing balancing, like a balancing thing like this almost.
Yeah, that's what I mean by
So if we have a thing on each side,
if you do like it's kind of like the equation on top. If you double one thing and you don't have it, it's imbalanced. But if you have it, then it will be balanced.
oh, okay. So if you see this as kind of 18 and 35, if we're going to half this side to 9 in order to keep it balanced, you think we have to double? Very good. All right, what your job is when you go back to your journals today is you are going to talk about which strategy makes the most sense to you and why. We're going to leave this up here so you can see all the different strategies. I want you to just tell me, and is there a reason a certain strategy works for this one? Like, what's your favorite strategy for this type of problem and why? Okay, very great job. Thank you so much.